So this is going to be modeling question 4 in my lab. When the given expression calculated as indicated, express your answer as a single polynomial in standard form. So again, we are adding and subtracting polynomials in this lesson. Notice how we have these 3 sets of parentheses. So there's this trinomial, and we're adding to this another trinomial, and we're subtracting a binomial. So polynomials that have 3 terms are called trinomials, and polynomials that have 2 terms are called binomials. So another thing we need to pick up on, as we mentioned, subtraction is equivalent to adding the opposite. So when we see 9 minus 4, remember, that's why I use kind of the circles. There's a 9 and there's a negative 4. So this can be interpreted as 9 plus a negative 4. So this is the same thing as saying 9 take away 4, but it's also the same thing as saying 9 and add the opposite of a 4, and the opposite of a 4 is a negative 4. So these are equivalent. So if I have like 10 take away a negative 1, this can be interpreted as 10 and and notice how this is the opposite of a negative 1. So really this is the same thing as 10 plus a 1. So those are equivalent. So remember, on a calculator, you can type it as 9 minus 4, or you can type it in as 9 plus a negative 4. They're equivalent. Or you can type it as 10 take away a negative 1, which gives you 11, or you can just simply say 10 plus a 1, which is 11. So my mindset is more about adding positive and negative numbers. So I will be following the rules of adding integers. So as I work through this example here, notice how we have these 3 polynomials. Now, what's tricky is with this one, we have just this 7x squared minus 5x plus 6, and we're adding to this 3x squared minus 8x plus 9. But notice how we're subtracting on this last one. Now, remember, subtraction, we really want to see this as adding the opposite. So what happens is, to work this problem out, this subtraction sign has to really be brought through the parentheses first. So in this problem right here, I actually go backwards and say, instead of subtracting this, I take the opposite of what's inside there. So that 7x squared turns into a negative 7x squared, and that plus 4x turns into a minus 4. So that plus 4 turns into a minus 4. Now, the rest of this can just drop down by it. So I have the 7x squared minus this 5x plus this 6 plus this 3x squared minus this 8x plus this 9. And that's how we now have subtraction of 9x squared, 7x squared minus 4. So again, what we're doing is combining like terms. So if we start with the highest degree, which is the squares, we have a 7x squared, we have a 3x squared, and we have a negative 7x squared. So those 3 things we're going to combine together. But notice how 7x squared and a negative 7x squared are opposites. In other words, 7 plus negative 7 is going to zero out. So I actually could just cancel those out, and that's just going to leave me this 3x squared. So the 3x squared would drop down. And so I've now combined my 3 terms there. But again, when you add, it doesn't matter what order you put that in. So then our next thing we're going with is the degree 1s. So there's this negative 5x, there's this negative 8x, and that's it. So those are the only 2. So if we have a negative 5 and a negative 8, that's a negative 13. So this will be a negative 13x. So those 2 terms are now combined. So what I'm left with now is I have this 6, and I have this 9, and I have this negative 4. So 6 plus 9 is 15. 15 lose 4 would be a positive 11. So I have I would have a plus 11 left there. So that's how I would kind of approach this, is remove the parentheses of the last term involving subtraction, and then bring down the rest of them, and then just start combining like terms by adding those coefficients together.